Okay, YouTube, this is our very first video on our exploration of the graphs of sine and cosine. In this video, what we're going to essentially do is look at what happens to the value of sine as the angle that we take here, the sine of, gets bigger and bigger and bigger and bigger, or maybe smaller and smaller and smaller and smaller. What are the patterns that we see there? And so in order to do this, what I want to start with is essentially creating a table of values here for this function y equals sine x and for this function y equals cosine x. But what we're going to start with is essentially this. When we see y equals sine x here, I'm going to rewrite this over here. A couple things that I want to write are these. First of all, that our x value really is representing what we take the sine of, which would be an angle. And sometimes you see people write the angle theta here. We're going to use the real number x to represent our theta. And so another thing of note here is that our angle is in radian measurement here, not degrees, but radians. But that being said, we say when we take the sine of an angle, what do we get? And we get the sine of that angle, but what I guess I'm trying to get at here is that the y value here represents what you get when you take the sine of that angle. So we'd say this is the value of, I would say sine at angle, and we're saying angle x. And so the same thing would be true down here for our cosine function, but essentially what we're saying is every ordered pair on our graph would have some angle, and then we would have sine of the angle at that point. And so when we make a table of values here, which is what I want to do here, let's go ahead and make a table of values. And this is for sine, so our tables are going to have to kind of be displaced a little bit because we wrote this right here for our sine, and we could certainly do that for cosine also. But what we're going to get here is this. Instead of x and y here, well, I guess let's write x and y. We do want to write x and y. But I also want to write this. We say angle. We'll put the angle in, and then we get the sine value. And so we're going to look at what happens to the value of sine. And the way we're going to do this is essentially we're going to use that unit circle. Now recall that the unit circle is a circle with a radius of 1 that's centered at the origin. So the important thing here is that the radius is 1. And that is to say that if you were to draw this unit circle, there are 4 points that we could distinctly show are on here, no doubt, hands down. These 4 points that are 1 unit to the right, north, I guess, east, north, west, and south of 0, 0. So we have 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And then all these intermediate values here are just kind of like multiples of 30, 30, 60, 90, 120, 150, 180. Or we could say multiples of 45, 45, 90, 135, 180. Or I suppose you could say multiples of 60. We say 60, 120, 180, and so on and so forth. That being said here, basically what we're going to do is we're going to input angles between 0 and 360 here for just a moment. So I'm going to do this in radians. We're going to say, okay, so starting at 0 degrees, 0 radians, we're going to put in 0. We say 0 radians. I'm going to draw a little line here. And then my next stop is the angle pi halves, or 90 degrees here. So half of a pi rotation. And then we say at a pi rotation, that would be the same thing as 2 pi halves, or 180 degrees here. So we would say at pi. Then we're going to go up another pi half. So we have 1 pi half, 2 pi halves, 3 pi halves. We're going to go down here to 270 degrees, 3 pi halves. And then for our last angle here for the moment, we're going to do is we're going to put in 2 pi, which would be a full rotation. Now, in terms of what we get for values here, one thing that I do want to remind us of is that on the unit circle, the interesting thing or the profound thing about all of these points on the perimeter of the unit circle here, they essentially tell us both the cosine is the x value of that angle, and then the sine value is the y value. But the sine of that angle is the y value, cosine is the x value at that angle. So the neat thing is all of these points right here are already telling us the value of, say, the sine or cosine of these things. So starting by acknowledging here that we're looking at what do we get when we plug in, this value for x. And I suppose I could show you, if y equals sine of x, we're plugging in 0. What we're really saying is what do we get when we put 0 in for x in our function here. So what's the sine of 0? And what I want to point out is in order to get the sine of 0, we'll just go look at the y value at a 0 radian angle. So looking at 0 radians, that would be facing directly in this direction right here. We look at the sine value, we say sine is 0. So we have sine of 0 is 0. Now let's rotate 90 degrees. And as we rotate 90 degrees, we say that the sine value, the y value there is 1. So we say sine of pi halves, or sine of 90 degrees is 1. Now let's go to a pi rotation here. If we go over to this angle, we say what's our sine value? Our sine value is back to 0. So we get back to 0. Sine of 3 pi halves, which is a rotation 270 degrees here, our sine value is negative 1. So we're going to put -1 as our output there. And then sine of 2 pi. If you were to go sine of 2 pi, the interesting thing is the sine of 2 pi is the same exact output values what we started with is 0. So we're kind of back to what we started with there, 0. And one thing that I kind of want to point out here is, and this is why I stopped at 2 pi, let's go ahead and add on, let's go to 5 pi halves. Let's go another pi half rotation, and then we'll go to 6 pi halves, which would be 3 pi. In other words, if I were to say now, let's go here, what I want you to see is that your sine value would be at 1 again, just like it was here when it was just at pi halves. So this angle here and this angle here are coterminal, so they have the same sine value. And if I were to go to like 3 pi, which would be 1 pi, 2 pi, 3 pi rotation, you would see that my sine value is back at 0, just like it was when I had just a pi rotation. And so those angles, when you look at those, we can say 1, 0. This set of outputs here from, I guess, like here back to here, it's just going to start repeating itself again once you start spinning over 360 degrees or 2 pi. So essentially what we're going to see here is that this function that we'll look at the graph of now just going to repeat itself over and over again. So what you're going to see on your graph, let's take a look at the graph of y equals sine of x. Where it says x, let's write this underneath. This is our axis that is representing our angle. So for instance, you can see that our angle starts at 0 and is going by 90-degree increments here. Pi halves, 2 pi halves, which is pi, 3 pi halves, 4 pi halves is 2 pi. And as our angle is getting bigger and bigger, what we're seeing is that the value of sine, check this out, sine starts at 0, and then it goes up to 1, and then it goes back down to 0. And then it goes to -1, and then it goes back up to 0. So when we're looking at our graph here, we're saying at 0 radians, 0, 0 is this point right here. At pi halves, when our angle is pi halves, we saw that our sine value is 1. So at pi halves, our graph is up at 1. And then what happened? Well, then it came back down again. We say now our sine value is 0 again over here. And then as we get down to 270 degrees, we see that it goes down to a value of -1 here on our graph, which was right here, this point right here. And then 2 pi, now we're back at 0. So after we get through a full 2 pi's worth of input here, you notice that your graph just starts to repeat itself again and again. And if we were to keep going around, look, your sine values, your y values would just keep going around and around and become 0, 1, 0, -1, 0, 1, 0, -1. It's just going to keep doing this over and over again. So with respect to our sine graph, what I'm going to tell you is we often indicate this interval of length right here. And what we're going to do is we're going to refer to this as the period of the graph. And when we refer to the period of the graph, we're referring to the amount of input or x value input you would have to go through before your graph just starts to repeat itself again. So if it started here, it goes through a full cycle and then it comes back to where it started at. We often also refer to the amplitude of the graph, which would be this vertical displacement here above and below what we call its midline. So we have its amplitude in this case is 1. So we say amplitude is equal to 1 because we went 1 above and 1 below our midline. So let's take a look at the graph of cosine. I'm going to scroll down a little bit here to give us a little bit more room. But if we were to make a table of values, let's go ahead and do that here for our cosine graph. Whoops, not sure why that's happening. Our table of values, let's go ahead and I'm going to make it horizontally here. We're going to say x, which is our angle, and then we say y, which is our cosine value at that angle. We're going to start at 0, and we're just going to go by 90-degree increments again. So pi halves, pi, 3 pi halves, and then 4 pi halves, which is 2 pi. And just looking at our unit circle here, the interesting thing I want us to notice is essentially that when you look at your unit circle, starting at 0 radians here, 0 degrees, your cosine values are your x values. So at 0 radians, what we're going to get is a cosine value of 1. And I'm going to go ahead and fill this in on our table here. So we say cosine of 0 is 1. Cosine at pi halves. Now when we look at pi halves, here we say the cosine at pi halves, which is this rotation right here, we see the cosine value becomes, the x value here is 0. And then we'd say at the next stop it'll be -1. I'm just going to fill in a couple of values here. So we have 0 at pi halves. You plug in pi halves, we get a cosine of pi halves is 0. Cosine at pi, so right here is this -1. Cosine at 3 pi halves down here is going to be back at 0 again. And then cosine at 2 pi, over here at 2 pi we get 1. And then after that it's just going to start to repeat itself again and again and again. And so we're going to refer to this also from an x value of 0 to an x value of 2 pi as one period, or I suppose we'll use this word also, one cycle of the graph here. So now, in terms of its amplitude, we can see that the amplitude, I'm going to write this on this graph also, amplitude is equal to 1 because this graph goes 1 above and 1 below its midline. So its amplitude is 1 here. And so the difference between sine and cosine. I suppose when we look at the graphs, sine starts off, when you look at your unit circle, since it's your y value, at 0. And so on our graph, it starts at 0, goes up, down, down, up. And with respect to our cosine graph, cosine already starts up at a high point here and then goes down, down, up, up. But in both of these graphs, what you can see are there are 5 key values. Okay, the one we start at, this one here, right here, right here, and then right here. And the same is true for our cosine graph. And so in terms of labeling these values, often what we're going to do is we're going to refer to any high points. We're going to refer to these as max values and any low points as min values of our graph. Likewise, we're going to refer to the high points, sometimes you hear it referred to as a crest, and sometimes when you talk about waves here, we refer to the low point as a trough. And so it's interesting to note here, or at least important to note, that when you talk about the graph of sine, the graph of sine starts at one of its zeros. It starts on the ground, goes up to its max and then a 0, and then min, then a 0. Cosine graph actually starts off at a maximum and then goes 0, minimum, 0, maximum in its cycle here. And so in the next video we're going to do is we're going to look at how we can, from the function here, from the equation of the function, how we can put together what we know about this graph in terms of amplitude and period. Cheers.